Alright, so I got a quick little demo here of my thermoelectric generator. We got a high quality thermoelectric generator here. Got a heat sink with thermal paste to the hot side, and then thermal glue adhering the thermoelectric generator to the bottom of the CPU cooler. 12-volt fan on the back. Got a boost converter here. The voltage output of the thermoelectric generator is currently 697, and the stable voltage of the boost converter powering the fan that's cooling the CPU cooler is at 15 volts. It's 3 volts over what it's rated, so I mean it's not a big deal, but it's getting close to where I wouldn't want to go any higher with the voltage to the 12-volt fan. So yep, this is a reading to the thermoelectric generator output voltage, and then this one's the reading to the boost converter powering the fan. To see the water vapor, or well, the liquid that's dripping off, condensing from the alcohol burning. So it is definitely staying nice and cold. I can touch this. It's not even hot. I mean, it's warm, but it's not gonna really burn me or anything. It's staying very cold. So it's working fantastic. The output is getting close to where I might be able to charge an external device along with running itself with a fan at this voltage. I'll probably try this next is by trying to charge a phone on top of powering itself. You know how thermoelectric generators aren't very efficient at all, but this one is actually pretty decent. I have to say it's probably maybe a I don't know on a max temperature difference it might be maybe it might be around 10 watts at most. I don't know, it's hard to say, but I should get like a voltage or a battery analyzer or something hooked to it too to see the amount of watts being consumed directly off of it. And then we can get a good accurate reading off of the output power from consumption and external output power. But this is a pretty good working concept of this. As you saw that the temperature was pretty high. I mean, we're getting close to a maximum temperature differential between the hot and cold plate. So you see 692 at the max on the hot side, and roughly 86, so roughly 87, 86 degrees, 85, 84 on the cold side. So that's a pretty big substantial difference in temperature there. And the voltage is staying pretty consistent. I mean, not on this, that's boost converter, but on this one is the thermoelectric generator output voltage. It does seem to be pretty stable around this voltage range. Either from 7 to 690 it stays around. Top fins are just lukewarm, like not that warm at all. So it's staying nice and cold. Technically, you could say this as like a thermoelectric generator and a kind of a heater, space heater in a way. So now we're around 707. And the best thing you want to make sure you have good thermal contact on both sides, but more importantly on the hot side, because as soon as the thing, because sometimes the thermal paste will let loose and it'll just drop. You can tell when it's happening because the voltage will just totally sag and it just won't work for shit. But yeah, you want to make sure you have very good thermal contact between the hot and the cold, but most importantly the hot side. But it's important on both, obviously, because otherwise it'll overheat the cold side. So yeah, you want to make sure to have good thermal contact. That's very important with any of these kind of devices. But yeah, we got some pretty good output. in my opinion. Cut out this board. Unfortunately, it split on me, but I cut out this board with my laser cutter. I wasn't even gonna do it. I was just gonna drill holes and cut a square board, but I had the laser cutter, so I'm gonna use it, right? And I got some brass with screws for like a table stand for it to sit on. Nice little unit. Well, I mean, also I could put this to help with the heat. Never even thought of that until now. Not that it'll really help a ton, but we'll see. Let's find out. Let's see if this helps it. So far, it doesn't seem to be doing much. I think that's more of a shield for like air blowing in to keep it from putting the or blowing the flame around. But the flame is pretty stable. Obviously, we're indoors, so that does help. But actually, it seems to be getting lower. Huh. Anyway, see you later, guys. This is where I'm at with this, and probably try to charge a phone or something at the same time of it running itself. All right, see you later.